when you have a conditional statement, like in this case, the conditional statement is, if you eat your dinner, then you can have dessert. There are three other statements that are related to the original. So the original, if you eat dinner is P, and you can have dessert is Q. So that's the original statement. A statement like this, if you don't eat your dinner, then you can't have dessert, which symbolically looks like that. That is called the inverse of the original. If you can have dessert, then you ate your dinner. That's Q implies P, and that is called the converse. And finally, if you can't have dessert, then you didn't eat your dinner. That's called the contrapositive. Not Q. And these things all kind of seem like they're saying the same thing as the original, but actually only one of them is. If you look here at the truth table, for every combination of P and Q, if you look at the truth table for the original, the converse, the inverse, and the contrapositive, only the contrapositive has exactly the same truth values as the original. The other two don't. So there could be situations where the original is true, but the converse is false, or when the original is false and the converse is true. However, you might notice that the converse and the inverse have the same truth table, so they are logically equivalent to each other. So the big thing to know is that the contrapositive is logically equivalent to the original conditional statement, but the other ones are not necessarily. A good way to see that is if I take my original statement is, if the number is 3, then the number is odd, which actually, in this case, we actually know it is true. However, when you reverse the P and the Q and you get, if the number is odd, the number is 3, that's actually not true, and you could think like a number like 5 is odd, but it's not a 3. Similarly with the inverse, which says if the number is not 3, then the number is not odd, that's false also, because like a number like 5 is not 3, but it is odd. But whereas it seems like maybe they're all going to be not logically equivalent, when you take this statement, if the number is 3, then the number is odd, and you take the contrapositive, you get, if the number is not odd, the number is not 3. And that's true. If it's not odd, if it's an even number, then there's no way it's the number 3. One type of question they could ask is to create the inverse or the converse or the contrapositive of a statement. In this case, the inverse of not P implies Q. So in the inverse, we negate both things and we kind of leave them in the same order. And not P is the same thing as P. And that is why the answer was choice 3. In this question, they say that this statement is true. They're telling you it's true. But it's not an if-then statement. So you would have to change it to something like, if it says all humans are mortal, that can be rephrased as, if you are a human, then you are mortal. So P is you're a human, and Q is you're mortal. When they say what must also be true, they're basically asking which of these 4 things is the contrapositive. Well, the contrapositive is not P implies not Q. Negate both, or just flip both. If they're positive, if it doesn't have a not, it gets one. If it has a not, it goes away. So the contrapositive is, if you're not mortal, then you're not human, and that's why number 3, Zeus is not mortal. If he's not mortal, therefore he's not human. And that concludes this lesson. What we learned in this lesson is the definitions of inverse, converse, and contrapositive. And that the contrapositive is logically equivalent to the original. Oh, and I should mention, sometimes there are some statements, like if I were to say something like, if it is a triangle, then it has 3 sides. That's a true statement. The converse in this case, the contrapositive is if it does not have 3 sides, it's not a triangle, and that's true. But the converse can be true, even if the original is true. It's not like it can't be. So if I say if it has 3 sides, if it has 3 sides, then it is a triangle. That can be true, but it didn't have to be true. It didn't have to have the same truth value the way the contrapositive has to. So I don't want you to think that the converse can't be true. And people even say in the English language, if it's a triangle that has 3 sides, and conversely, if it has 3 sides, it's a triangle. They're saying in this situation, they're telling you that the converse is logically equivalent to the original. And in that case, all 4 things would be logically equivalent. But in general, any statement, the contrapositive is logically equivalent to the original. And that's the end of this lesson.